All right, good morning, viewers. Good morning, students. This is Supreme Education Foundation Schools, Year 11 Mathematics class. Today, we'll be looking at the revision into all the things we've learned so far in probability. My name is Mr. Ayodeji Ogunyeye, and I'll be your tutor today. Okay. In this revision, the objectives are understanding the probability scale, which we've treated already, finding probabilities using equally likely outcomes. That's when you want to deal with theoretical probabilities, the real calculations. Now, also students are meant to know that the sum of probabilities is 1, and that talks about the fact that, when you have an event, all the possible outcomes of that event, all their probabilities will always add up to 1. Okay, it has to be exhaustive for you to have that. Now, students must also be able to list outcomes using tables. We've treated that in listing outcomes. And then the use of two-way tables is necessary. We've also treated that. So let's look at them all over again and revise them. Let's get right to it. Now, the probability scale goes from 0 to 1. That has been treated. You need to match the letters to the correct descriptions that we have over here. Okay, guys, let's get to it. Unlikely. Where should unlikely be in this probability scale? All right. So you have letters from A to E. Which letter would you write here that could represent unlikely? Of course, if I should remind you, probability of 1 is for certain. Probability of 0 is definitely for impossible. So unlikely should be close to impossible. So this goes for B. Impossible itself, of course, that is probability of 0, so that is C. Evens, of course, that is the E pointer. That's for 0.5. Certain, of course, that is A, probability of 1. Likely should be somewhere close to certain, so that is going to be D. Let's mark it. All correct. Well done. Moving on. Now, if all outcomes in an experiment are equally likely, the probability of any event is found using the formula below. I remember giving you that the word that you have there that is called successful, okay, the word successful over here, we can also use the word required. Okay, we should take note of that. We can also use the word required. So I could do it this way. We can use the word required. And required in the sense that that is what the question is requiring us to find its probability. So if you want to put it that way, I can put it on top of successful to show that that is another word. Okay, that is another word for successful. All right, over total number of, okay, I would like to include over here, or just let me put it this way, guys, so that we won't have any issues understanding what I'm talking about. I'm going to say or, meaning that I'm putting out another formula, GGET, for probability. Probability, and I would like to say that probability is equal to the number of required outcomes. Okay. I'm going to have all of this to be divided by okay, total number of possible. I like the word possible in there. possible outcomes. It's very important that we mention the word possible outcomes in the formula. So I'm gonna go with this formula, this particular formula. I prefer this at all times. The word successful is also very nice, okay, because what you are required to do, the outcomes that are required of you are actually your successes. So it's also very, very good. But I go with this or either that as well, still does the job. So guys, take note of that, very, very important. All of these have been explained already in previous lessons. We're just revising them, reminding ourselves of the formulas, of what each of these things mean, and what have you. So moving on from the formula stated, I'm just going to remove all this. I hope you've noted them. Okay. If an unbiased dice is rolled, what is the probability of getting an even number? Of course, well, number of successful outcomes, meaning that how many even numbers, your required outcome is even numbers. How many of them do we have on a dice? We have just 3, which is 2, 4, or 6. Total number of possible outcomes, meaning that your dice itself, how many numbers are there on a dice? There's 6 of them, 1, 2, 3, 4, 5, 6. So definitely probability of an even number is successful outcomes over possible outcomes, which is 3 over 6 to have 1 over 2. Remember, we can shorten how we write it this way by just simply writing P bracket even number. It already means that we are saying that the probability of getting an even number. So that is clear to us as well. Moving on. Now, the experiment or trial is rolling an unbiased dice because it is unbiased. You have to perform an experiment, and the event is getting an even number. This is just trying to tell us that there's a difference between experiment and event. Okay, experiment is also considered as trial because in an experiment you do a lot of trials, so you can say number of trials in rolling an unbiased dice. When we now talk about event is referring to the successful outcomes that you want, the required outcome that they're asking you to get. Okay, so what is required of us is to get an even number. The success we want is to get an even number. That is the event. So take note of that, guys. Okay, that is the event. Okay, now the outcomes. Okay, the event is getting an even number. Then the outcomes are the possible results. Okay, we can have outcome for event. We can have outcome for an experiment. Okay, the outcome, possible outcomes for the dice is definitely 6. Okay, all right, but the successful outcomes are the even numbers, which is 2, 4, and 6. Probabilities are always written as fractions, decimals, or percentages. Let's take note of that. Okay, and also we can therefore do this and solve these probabilities based on the knowledge we have so far. It would do us a lot of good, guys, for me to quickly also put in here where we are talking about probabilities always written as fractions, decimal, and percentages. I would also quickly want to say, since we are revising, that the probability of any event E, okay, the probability of any event E, all right, is always strictly, take note of this, guys, always strictly between 2 numbers, okay? This is important for us to take to heart. Always between 2 numbers, all right? You must remember this at all times when you are doing any calculation on probability. And the reason for that is simply because you need to take note of the fact that when you are doing your calculation, okay, you might be tempted to think, all right, that maybe what you have done is correct. But a quick check is that the probability of any event, okay, we know what event is now, is always from 0 to 1. You saw it also on the probability scale, always from 0 to 1. If your answer is, guys, if your answer that you got is more than 1, above 1, just know you are wrong. You don't need to even think about it. Know you are wrong and then go to trace your steps and check your errors. If your probability answer is actually, below 0, that's negative. Just know you are wrong. So go back and check your errors and make sure you understand that. Basically, what I'm actually supposed to write in a mathematical sense when I wrote this, 0 to 1 for probability for any event, is actually to do this. So I'm going to quickly, remove these arrows and put the right, let me use my writing pen. I'm supposed to have this to be less than or equal to here, and also less than or equal to here. Mathematically speaking, that actually means that the probability of any event is from 0 to 1. That means 0 and 1 are inclusive. So take note of that, guys. 0 is part of them, 1 is part of them. And all the numbers in between 0 and 1 are all possible answers for the probability of any event. Okay, let's continue. Now, we want to find the probabilities below. A number smaller than 4. We are talking about a dice, guys. A number smaller than 4. How many numbers are smaller than 4 on a dice? Okay, just 1, 2, 3. So that means there are 3 numbers and then over 6. So I'm going to expect to break that down to 1 over 2 is lowest form. Remember, we always reduce to the lowest terms. Now, probability of not a 6. Not a 6. Well, if it is not a 6, then it has to be other numbers that are not 6, which are 1, 2, 3, 4, 5. So 5 numbers are not 6. So that will be 5 over 6. Now for this part where we are right now, I'm going to do this because there's another way to do this, which I'm going to quickly explain. I've told you that before. We are revising, don't forget, guys. The probability of an event not happening, okay, so it's going to be like probability of a 6. Probability of a 6, okay, is going to be equal to, based on the formula that we know already, is going to be equal to 1 minus the probability of a 6. Okay, the probability of a 6. I'm sure you guys are wondering that, sorry, shouldn't be a bar on the first? Yes, I'm going to put it. I'm going to put it. So there should be a straight line bar on top of this to explain that you are talking about probability of not a 6. The bar on top, okay, this particular bar that I have on top of a 6 here is representing not. In some textbook, they could use prime, but I prefer using bar for my own. So probability of not a 6 is 1 minus probability of a 6. Remember that formula that we gave is very important, okay? So to finish up this calculation, it's just simply going to be equal to 1 minus, so you guys think about it. What is the probability of getting a 6 on a dice? How many 6 do I have on a dice? Just 1. So this is 1 minus 1 over 6. You can see that I'm going to end up getting the same answer as before because 1 minus 1 over 6 is 5 over 6. So I believe that is very much explanatory. So sometimes instead of thinking of the other things that are not 6, you can just do 1 minus 6 itself. So you can apply that to other type of questions that comes in this format. Okay, let's mark it and move on. All correct. Well done. Moving on. Let me clear my drawings. Now, here we have a number is chosen at random from the whole numbers 1 to 50. Find the probability that the number is, okay, we have questions to solve. You can see that here the format of putting our answer is not in fraction like before. So that means they want our answers in decimal. Okay, so please take note of that. So for an odd number, how many odd numbers do you have from 1 to 50? How many odd numbers do you have from 1 to 50? Of course, if you think about that very well, you will know that you should definitely have 25 odd numbers because From 1 to 50, you have 25 odd numbers and 25 even numbers. So this should be 25 over 50. And when you reduce that, you should get 1 over 2. And definitely, if that is that, and our answer should be in decimal, you will expect your decimal answer here to definitely be 0.5. Now let's move to the next one. Less than 31. Probability that the number is less than 31. So the question is, how many numbers are less than 31 from 1 to 50? So you know you're going to have to count from 1 to 30. Okay, so I believe that is, I just counted it. 1 to 30 are all less than 31. So the probability is 30 out of 50. So if you reduce that, you get 3 over 5, and 3 over 5 in decimal. When you do it, you should get as your answer now, okay, for 3 over 5, that should be equal to 0.6. So I put in there 0.6. I move to the next one. Probability that the number is greater than 32. If it is greater than 32, I'm going to expect to have all the numbers that are greater than 32. How many are they? So you start counting from 33. Okay, so 33, 34, 35, 36, 37, 38, 39, 40. Okay, so that's going to give you about 23. Okay, that's going to give you about 18 numbers altogether. Okay, 18 numbers altogether. All right, let's count it very well and be sure. Greater than 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Yes, we were correct. So that is 18 over 50. And when you break that down, maybe to its lowest form, or you just go straight for its fraction, for its decimal, you could also quickly do that. Okay, since you know you want the decimal number. So 18 divided by 50 in decimal is going to give you 0.36. So over here, the answer in here should be 0.36. Moving on to the next one. We know how it goes now, so I'm just going to drop the answer. We need the probability that the number is greater than 20, but less than 46. Greater than 20, but less than 46. That is a range. That's between 20 and 46, okay? Remember, it's greater and less. So that means 20 is not there and 46 is not there. So you start with 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. You want 35, 36, 37, 38, 39, 40, okay? And then 45. So you have about 25 numbers right there. So you expect to land on 0.5 for this as well. A multiple of 6, that's like your 6 multiple table. So you start from 6, 12, 18, 24, 30, 36, 42, 48. So all the numbers that are multiples of 6, we have about 8 of them. So, so 8 of them. So that means you have 8 out of 50. 8 divided by 50 in decimal should give you 0.16. 0.16. So let's see if we didn't make any mistake. All correct. Well done, guys. So that is how that goes. Moving on. Now, we remember that we said that probabilities always add up to 1. Now, what we mean, in essence, is that the probabilities of all the possible, okay, all the possible outcomes of an event, okay, must always add up to 1. Now, the event here is about Jack, okay, getting to school. Now, and all the possible ways of Jack getting to school, all right, are either he gets there early, he gets there on time, or he gets there late. Those are the 3 possible outcomes, okay, for Jack. So the probabilities of all those outcomes, if you add them together, it must be equal to 1. Let's put that down very quickly. So this is what we're trying, let me put it here. This is what we're trying to say. So the probability of early plus the probability of on time, okay, and then plus the probability of late. These are the possible outcomes. The addition of all those probabilities must be equal to 1. It's an important aspect of probability that we must know. So this is exhaustive. There's no other possible outcome. It's exhaustive. Early, on time, late. That's everything you can talk about him getting to school. Okay. What is the probability of him being late? So we are looking for late. So if you want to do that, definitely you must know that probability of his lateness from what we just wrote out is expected to be equal to 1 minus the addition, okay? 1 minus the addition of probability of him being early, right? Him being early, and then plus the probability of him being on time. Being on time. So that is what we're going to work with. So take note of that, guys. Very important for us to understand these concepts. So let's pull through and see how we're going to get our answer here. So as you can see, probability of early or on time over here. Okay, I need to put a closure for this bracket over here. Yes, yeah. So we see it now that on time or on early, which is probability early plus probability on time. We'll still discuss about that in our next video, the next lesson rather. 0.62 plus 0.06, which they were given to us in the question, that is 0.68. So definitely the probability of him being late is going to be 1 minus 0.68, which is 0.32. I believe this is very clear and very understandable. So remember, you can extend it to any other event. Let me just quickly give you a practical event to confirm what this is all about. Let's talk about the event of a dice, okay? A dice has how many faces? 6 faces, okay? There are 6 numbers there, 1 to 6. Now, exhaustively, all the possible outcomes is 6, the 1 to 6. So probability of getting a 1 plus the probability of getting a 2 plus the probability of getting a 3, probability of getting a 4, and so on and so forth, okay, must be equal to 1. Let's quickly confirm that. So that's what we're trying to talk about right now. Let's see that for a dice. Probability of 1, getting a 1, plus the probability of getting a 2, okay, plus the probability of getting a 3, plus the probability of getting a 4, plus the probability of getting a 5, and lastly, plus the probability of getting this, a 6. So take a look at this, guys. All those probabilities that you're looking at, we are saying that compulsorily the answer must be equal to 1. That's what we're talking about. But let us confirm and be sure that what we're even talking about is actually true. The probability of getting a 1 on a dice, we all know, is 1 over 6. Plus, for a 2, definitely 1 over 6 as well. So you can see the trend now, what is going on here. Plus 1 over 6, plus 1 over 6. Okay, plus 1 over 6. Okay, and lastly, plus 1 over 6. Because the probabilities of each of them is actually 1 over 6. So if you do the addition of all of that, I'm sure we all know that you should get 6 over 6, which is definitely equal to 1. So that confirms to us that that rule is correct. Exhaustively, the probability of all possible outcomes must definitely always be equal to 1. And that is perfectly explained. Moving on, guys. For experiments with 2 parts, we're revising, we've done it in previous lesson. It is useful to list outcomes in tables. For example, 2 dice are rolled and the larger score is recorded. You create a table of this nature. If you look at this, you can see the pattern, the way this table is going. Dice 1, 1, 2, 3, 4, 5, 6. Dice 2, 1, 2, 3, 4, 5, 6. Okay, we just have 1 here. I can see 2, 2, 2 here. I can see 3, 3, 3, 3 this way. 4, 4, 4, 4 this way. So I think all of this should just go down with, should just go down with 5s. So this should be 5, 5, 5, 5, 5. And I go this way, 5, 5, 5, 5. Then this should be 6. Following that pattern, this should be 6, 6, 6, 6, 6, 6, 6, 6, 6, 6. Mark it, all correct. Well done. Now, find the probability that the larger score is 3. So we're going to come into our table for all the possible outcomes. We already know from this table that the total number of possible outcomes is 36. Just 6 times 6. We've done that before. Just revising. 6 numbers here, 6 numbers here. We expect 36 outcomes, okay? So for probability of scores larger than, that the larger score is 3. We are always recording the larger score. So which score here is 3? This is 3, this is 3, this is 3, this is 3, this is 3. How many of you do I have? I have 5. So the probability should be 5, because successful outcome is 5. Probability should be 5 over 36, because the total number of outcomes when you count or you just multiply is 36. So probability larger score is 3, is 5 over 36. Now let's use that knowledge to actually do all of these guys too. Find these probabilities. Larger score is 6. How many 6 do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this should be 11 over 36. The next one, larger score is odd. Oh, all odd numbers. This is 1 plus 5, that is 6, plus this is 1, 2, 3, okay, 4, 5, then plus 4, 9. So that is 1, 5, 9. So 6 plus 9 should give us 15. And then divided by 36. Lastly, larger score is at least 5. Remember what we explained when we always use the word at least. At least means that number and above. So minimum is 5 and above. But when we use the word at least, it's not just that the number should be 5. We are saying minimum is 5. And when we say minimum is 5, it means from 5 above. So that is the meaning of at least 5. So if you check that, at least 5 will mean from 5 above. The above is just 6. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then over here we have 11. 1, 2, 3, 4, 5. Yeah, 11. So 11 plus 9 should give 20. So that should be 20 over 36. Let's mark it all correct. Next, we now want to use the idea of, find the most and least likely outcomes. The most likely outcome is definitely the one that has the highest number, okay, of occurrence. That's the most likely outcome, and that is 6. The one that has the least likely outcome is the one that is like it's not even there. And if I can watch the table, I can see that 1 appeared only once. So that should be 1. And that is what we're talking about. Okay, moving on. You need to be able to find probabilities from two-way tables. We've done that already in previous classes as well. Take a look at this table. It shows the age distribution of the members of a youth club. And from that table, we want to know if a member is picked at random, what is the probability that they are 12-year-old boy? So our focus is 12 years, okay? 12 years, and our focus, that is a boy. So we have 13, okay? So successful outcome is 13. Now, total number of possible outcomes is the total, because they said if a member is picked at random, so the whole members is our possible outcomes, which is 61. Okay, you have to be careful there. Always take note of the question. A member is picked at random. A member, not a girl, not a boy, a member. So the total is 61. So you have 13 over 61 for that. Okay, 13 of the members are 12-year-old boys, and there are 61 members all together. Now, if a member is picked at random, so that means all members, 61. What is the probability that they are a girl? Of course, girls, the total of girls, we have to talk about girls now, is 26. So that should be 26 over 61. And that is correct. Let's try another one. If a girl is picked at random, can you see it now? Not a member anymore. If a girl is picked at random, so the total number of possible outcomes for girls is 26. No more, we will not be using 61 again. Here to be 26 now, okay? And then we want it to be the probability that she is 13 years old. So I'm going to go to 13 years. So how many girls are 13 years? That is 6. So you have 6 over 26, and that is correct. Well done, guys. So that is how that goes. And then finally, on our final slide, the table shows the distribution of the audience at a play. Find the missing values. Oh, of course. Based on what we understand about the two-way table, the total here, it should be the total of 34 plus 43 plus balcony here that are adults to give us 110. So it means that to get the value here, you have to add 34 plus 43, okay, and then subtract it from 110, okay, and that should give you 33. So this place is 33, this is 33, okay. Now, the next thing is, let's look for here. For stalls, 34 plus 30 should be added together to give 66 over there. 33 plus 37 here should give all balcony, and that should give 70. Excuse me. Likewise here, the total is already 66 for all circles. All circles. So you just do 66 minus 43 to get what you will have here. So 66 minus 43 should give us 23. So this place is 23. And finally, I can get this place now, because 32 plus 23 plus 37 should give me this value here. So if you do 32 plus 23, okay, 32 plus 23, and then you also add it up to 37, that should give you 92. And then finally, your answer here should be 110 plus 92, or you can do 66 plus 66 plus 70. In that way, this answer must tally for those additions. So 92 plus 110 should give us 202. Should give us 202. Okay. Let's see, did we make any error? Oh, okay, yeah, we are correct. 202. 202, that's a double 66 there. So you could do 66 plus 66 and then plus 70. You should also get 202, and that's the correct answer there. So let's see what we have next after that. Let's mark this first, okay? All correct, well done. Next, we want to find if a member of the audience is chosen at random, find the probability that they are a child in the circle. A child in the circle, so a member. So since it's just a member, it should be 202. So the member we are looking for now is a child in the circle. So children and circle, this is where they are, 23 of them. So you have 23 over that. And adults, well, we already know it's the entire audience, so 202 again for the possible outcomes. And audience, what's the total? Sorry, an adult rather. Adults, all the adults. What's the total? 110. So we have 110 adults, so over 202. Finally, in the stalls. So the total of stalls is 66. So we have 66 of them, and definitely entire members is 2202. Let's mark it. All correct. Well done, guys. Let's try another one. If an adult is chosen at random, can you see the condition now? It is an adult that is chosen at random now. So focus is on adult. Total of adults where are possible now. So that should be 110 now. If an adult is chosen at random, find the probability that they are in stalls. So how many adults are in stalls? That's 34 right here. So you have 34. And the next one, if someone in the circle is chosen at random, so our total number of possible outcomes for circle is the total of circle, which is 66 now. So this has to be 66. So what is the question? Probability that they are a child. So children in circle, 23. So that will be 23 over 66. All correct. So I want to believe that with this lesson today, you have been able to understand, okay, and revise on the things that we learned before. This will help you to do your assignments, okay, on this probability revision. Thank you guys for being in class today. I believe you enjoyed the class. Okay, go do your assignment now and then submit. All right, thank you so much. Thank you very much. I'm going to see you guys in the next class. Okay? All right, do your assignment, submit on time so that you can get your scores. Thank you so much once again, and bye for now. See you in the next class. Bye, guys.